Beekeepers the world over are worried about the impacts that pesticides have on their honeybees. Pesticides are a really big deal. You hear people talk about it all the time. If you look at the chat forums, if you go to the bee meetings, I get a lot of emails about this as well. Pesticides are always on the forefront of beekeepers' minds. And yes, pesticides kill bees. They do it every year. However, I want to use this video to talk about the risk associated with pesticides and honeybees. Just because something is toxic doesn't mean that it poses a high risk to honeybees. So it's important to understand some terminology associated with pesticides, some terminology associated with toxicology, so that you can appreciate the threat that pesticides pose to bees in a lot of different scenarios. The first thing I want to do is start by defining some terms. There's an entire field called toxicology, and in this field there are scientists who are toxicologists who study the impacts, the effects of pesticides on all sorts of things. If you think about it from a practical perspective, toxicologists even study new pesticide chemistries because their goal is to maximize the impact of a pesticide on a target organism, but minimize the impact of that pesticide on a non-target organism. We have pesticides because pesticides are used to control pests. If it controls a rodent, it's a rodenticide. If it controls a fungus, it's a fungicide. If it controls a plant, it's an herbicide, and so forth. Of course, honeybees are insects, so generally speaking, when we think about pesticide impacts on honeybees, we're thinking specifically about insecticide impacts on honeybees, but there's some research out there that suggests that other things, such as fungicides as an example, or maybe in some context, even herbicides, can play a role in honeybee colony health. So thinking about toxicology, it's very important to start with this very basic idea, this concept of risk. When most people think about honeybees and impacts of pesticides, they think of toxicity. Well, risk is a larger umbrella that encompasses the toxic impact of pesticides on bees, but as a function of exposure. So what do I mean? Well, risk is really a function of toxicity, how toxic is something to honeybees in this case, and exposure. For example, things can have really high toxicities. In other words, it takes only a small amount to impact the bees. It can have a really high toxicity, but if the exposure is incredibly low or even zero, then it doesn't matter how toxic the compound is. Bees aren't getting exposed to enough of it to suffer an impact. In contrast, it can have low toxicity, but high exposure and even result in high risk simply because the bees get exposed to a lot of it. So understanding risk then is understanding toxicity and exposure. And really, toxicity is the ability of any compound to elicit an abnormal effect on an organism. When we think pesticides, we think death, right? You put out an insecticide, you hope to kill an insect. But that's not toxicity by itself. Toxicity doesn't have to result in death. It can impact reproduction. It can impact nutritional utilization. It can impact so many different things. So within then this concept of toxicity, we go further down to two broad categories, one of those being acute toxicity and the second of those being chronic toxicity. Without getting into the weeds, when I think about acute toxicity, I think about how a single exposure over a short period of time has the ability to elicit a toxic effect on the organism. Again, this video is about honeybees, so I could really be talking about any number of different things, but I'm going to focus in on honeybees. So something that is acutely toxic to honeybees means that honeybees may only need to be exposed one time to a small amount of it to elicit an effect. Now, something can be acutely toxic if it's even exposed in a large amount. If they just get it one single time or maybe one single episode to elicit that toxic effect. It's an overgeneralization, but when we think of acute responses in honeybees, we often think dead bees. Piles of dead bees at the nest entrance, maybe bees dying in the field after that single exposure to a high amount. In contrast, chronic toxicity are usually smaller exposures happening to bees over a period of time. Now, something can have a high toxicity, be very toxic to bees, but if it's only delivered in small amounts over a period of time, you get this chronic exposure that may not kill the bees outright, but might lead to something that all beekeepers talk about in the message boards, which are sublethal effects. The word sublethal tells you exactly what it means, an effect that is sub or below lethality. In other words, bees are getting exposed to a compound that doesn't produce a lethal effect, but they're getting chronically exposed, and it might lead to reproductive effects, susceptibility to other diseases and pests, etc. So toxicity is the ability of a substance to elicit some sort of negative response in an organism. Acute exposure, acute toxicity means they get that single dose or that one exposure, whereas a chronic toxicity, they're getting consistently exposed to this compound over a period of time. You hear a lot of toxicologists say the dose makes the poison. That's a very common adage in toxicology. The idea means that anything can be toxic if you simply get exposed enough to it. And like I said, toxic means that the compound elicits some sort of response in the organism. But in all these definitions I've been sharing, you've been hearing me use the word exposure, 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 exposure. Well, exposure is the other half of that risk calculation. You've got toxicity, but you've got exposure. So how are then honeybees exposed to pesticides? We'll say insecticides, fungicides, herbicides, whatever side that you want. How are honeybees exposed to them? It really boils down to two major areas where they are exposed. They're either exposed outside of the hive or nest or inside of the hive or nest. And let's focus specifically outside the hive or nest first. Honeybees, especially worker bees, constantly leave the hive to go out into an environment that's full of pesticides. People are spraying pesticides to control pests on crops. They're putting herbicides around their house to control weeds. They might be treating their house for termites. There's lots of pesticides available in the environment. Bees go outside of their nests, and they can become exposed. A few routes of exposure include a direct route, which means that bee is passing through an application of pesticide. For example, think about someone actively treating row crops where honeybees are flying through. They are getting direct contact from those sprays. Another route of exposure is if a bee lands on the foliage of a treated plant. Maybe something has been put out in the environment to treat a particular plant for a pest that plant may have, and a bee lands on it, they can get contact exposure. There's also exposure outside the nest through consumption. Bees can be exposed to pesticides when they take pollen onto their bodies, when they take nectar into their bodies from treated flowers. And it doesn't even have to be a treatment applied physically to the flower. It can actually be applied to the ground around the flower, because there's plenty of compounds available today that have a systemic action, which means they are taken up in the plant and released through the nectar or associated with the pollen, etc. There are even things that beekeepers may or may not consider. Bees need water to thermoregulate their nest. They go out to water, they collect it, they bring it into their bodies, and they fly it back to the nest. There can be pesticide runoff in the places where bees collect water. To go a step further, there's even something called guttation fluid. In some cases, plants that are treated as seeds with systemic insecticides, when they are planted, they grow and the plant can express that pesticide in its tissue. And early in the morning, the plant may weep. It may secrete water, guttation fluid, and bees will come and collect that fluid to take back to the nest. You then got bees taking pesticide-laden foodstuffs into their bodies, or packing it on their hind legs, or being exposed directly through spray or contacting foliage, etc. And that can lead to bee deaths in the field. If the pesticide has an acute toxicity that is high enough to kill the bee won't even make it back to the nest. That outside the nest, that outside the hive exposure can kill them in the field. If, on the other hand, the residue level to which the bees are exposed doesn't reach that level of acute toxicity, the bees will be able to survive contact with that pesticide and then fly that pesticide and its residues back to the nest, where you may then get chronic exposure. And inside the hive, there are lots of different ways bees can be exposed to pesticides. Think back to everything I told you outside the nest, the collection of nectar, the collection of pollen, the collection of propolis or tree saps or resins, the collection of water. If all of that stuff comes back to the nest and is deposited into the nest, then you can start seeing pesticides in multiple matrices to which bees get exposed. It might show up in the stored pollen or bee bread that bees consume. It might show up in the stored nectar, which is converted to honey, both of which bees consume. The pesticides might go into the wax infrastructure, that wax comb that the bees live on in the nest. In fact, many of the compounds to which bees are exposed are lipophilic. Lipo meaning wax, philic meaning loving. So lipophilic means the compound is wax loving, which means chemically it wants to be in the wax. So it'll go into the wax and bees can get exposed to those compounds through topically, interaction with the wax. And lots of different things happen in beeswax. Bees walk on it, they're reared in it, they store their food in it, and so forth. Some of these compounds may even show up in the royal jelly that the bees use to feed to their queens or the brood food that they use to feed to the developing workers or drones. Therefore, there are many different routes of exposure, both outside the hive and inside the hive. So I want to broaden it, give you a big overview. A single honeybee colony can have a 3 to 5 mile foraging radius. If you work that math out, up to the 5 miles, that means a single honeybee colony can forage an area of up to 80 square miles or 200 square kilometers. That means a single honeybee colony is canvassing an incredibly large area where the bees are being exposed to compounds topically through flight, through collecting foodstuffs, and then gathering all of that. And if it's at an acute level and the compound's highly toxic, the bee may die from exposure in the field. If it's not an acute exposure and the compound has low toxicity, the bee may bring it back to the nest where it shows up in the wax, the food, etc. So these two routes of exposure, both outside the hive and inside the hive, lead to this complex interaction between honeybees and the pesticides that are used in the environment. And I might mention the most direct exposure that honeybees have to pesticides usually comes in the form of what beekeepers apply in the nest to control varroa or small hive beetles or the other chemicals that they use to control the diseases or other pests that are in the nest. Not only do bees get exposed outside the hive to things that other people are using, but also inside the hive to things that beekeepers use as well. Keeping all of this in mind and bringing back in what we know about toxicity, both acute and chronic, and what we know about exposure, we can put the two of those together to think about how toxicity and exposure drive risk. With toxicity and exposure in mind, I want to talk about something else that will play off of both of these things before I finish this video bringing it all together and talking specifically about risk. And that thing is something that we call pesticide formulation. You could even layer on top of that pesticide application. What do I mean by that? Well, a pesticide is some sort of product that contains an active ingredient, which is the compound doing the work, and inert ingredients. The job of the inert ingredients is to help the active ingredient together achieve the goal of pest control. Just a hypothetical. Let's say this compound is not very stable in the environment as an active ingredient. If you put it in the environment, it may wash away, the sun may degrade it. Well, let's layer on top of that then that mixing it with these inert ingredients allow it now to stick more firmly to the leaf. So sunshine can't degrade it quickly, rain can't wash it away for a few days. It amplifies or enhances the impact of the active ingredient. So a pesticide with its active ingredient and inert ingredients together is called the formulation. You hear a lot of scientists talk about the active ingredient because that's the compound doing the work. But it's equally appropriate, maybe even more so, to talk about the formulation. And when you think about formulations, not all formulations are created equal. The same active ingredient may be formulated multiple different ways. It may be formulated in a liquid. It may be formulated in a micro-encapsulated pellet. It may be formulated in a granular. It may be formulated in a dust or a bait. The same active ingredient then, whose toxicity doesn't change, can be formulated multiple ways, which will impact the bee's exposure to that active ingredient. To give you a very practical example, the same active ingredient in a liquid might not impact bees as much as that same active ingredient does in a dust, because the bees may collect that dust like pollen and fly back to the nest and store it like pollen and consume it like pollen. Therefore, when thinking about toxicity and you think about formulations, that formulation can drive some of the impacts that we see. I want to illustrate that by giving you a brief list of some formulations and talk about their relative toxicity to other formulations available. Let's consider this idea of formulations a little bit further. I'm not going to go over all the formulations that exist in the pesticide world, but I will point out a few different things. For example, micro-encapsulated insecticides tend to be worse for honeybees, not necessarily because the active ingredient in them is more or less toxic to honeybees than in other formulations, but because the formulation itself, this exposure route, can be very detrimental to bees. Bees can, for example, collect micro-encapsulated insecticides like pollen and fly it back to their nest and store, and it shows up later. Similarly, dusts are not really good formulations for bees. The same active ingredient in a liquid may be nearly innocuous to bees, that the same active ingredient in a dust may kill the entire colony. Moving up the scale, we have things like wettable powders, which have particles that form a suspension that don't usually dissolve in water. This might be the next most toxic formulation. Moving to ultra-low volume formulations, emulsifiable concentrates, seed coatings. Seed coatings get a lot of attention because they're used so commonly, especially in the class of insecticides with neonicotinoids. So people worry about the seed coatings on seeds and these compounds showing up later in the plant tissues. So moving up the not so good for you formulation list, seed coatings tend to be less of a problem than things such as dust and microencapsulated insecticides. Then moving from there, granular formulations tend to be the least hazardous formulation to bees because they're so large. It's really hard for bees to get exposed to the compound in these granular formulations. Bees can't really fly these big granules back to the nest. And then moving even up further, baits, very targeted baits where bees can't even get into and exposed to the baits can be even less of a problem for bees if the bait is something that bees would not normally collect. Toxicity then and exposure then can be mitigated in part through formulation choice. I know I have gone over a lot of technical terms with you about pesticide impacts on bees. I really want to bring it all together. We worry, like you worry, about pesticide impacts on bees. We want to make sure that when pesticides are applied, they do exactly what they say they're going to do while offering no non-target effects at all. Or we need to find ways to mitigate those non-target impacts. Thinking then about toxicity, exposure, and risk. I hear so many people talk about the toxicity of a compound to bees, and that's really only half of the story. What really needs to drive this discussion is risk. When something is toxic and the exposure scenario is correct, it can increase the risk to bees. I had an amazing postdoc in my lab who told me a story years ago. I won't say his name to protect his identity, but if you ever watch this video, you know who you are. He told me this way of thinking about risk. And I love this story, so bear with me for just a moment. It seems to pivot away from pesticides, but I promise it's relevant. Lions are 100% toxic to humans. If you encounter a lion, there's no barrier between you and the lion wants to kill you, there's not much you're going to be able to do. If you encounter that lion on the Serengeti, there's a high toxicity and a high exposure, which leads to a high risk to you. Now take that same lion and put it behind bars in a zoo. The toxicity has not changed, but the exposure has. unless you put your arms or your head in the bar, there's not going to be a great risk to you. Toxicity is still high, but exposure is moderate, so the risk is moderate. Now take that same lion and put it in a different zoo behind a glass wall. The toxicity remains high, but the exposure is almost non-existent. Unless you walk around and jump into the cage, you won't be exposed. Therefore, with high toxicity and low exposure, you get low risk. When you just talk about toxicity, you don't have the whole picture. We really need to understand how toxic a compound is to bees, the routes of exposure in the field and in their hive, and put those together to understand and mitigate risk. And sometimes it's as simple as changing the formulation or changing the active ingredient. I'm going to talk about risk mitigation in another video, but I really wanted to introduce you in this video to the idea of toxicity, how things can cause responses in bees, how they get exposed, to help you think about the risk that pesticides pose to bees.